Figure 1 shows an incomplete diagram of experimental setup that can be used to verify Charles' law. I will use this rough diagram to explain. Part A. Up to what level? A, B, C or D? Should water be filled in the cylinder in order to perform the experiment accurately? We have to fill up to A. It is the maximum marked height. Up to A. Because of we have to write only a level. Therefore, don't explain. I will explain why why we are using water level up to A. We know that according to Charles' law, volume is directly proportional to absolute temperature. Then we are trying to increase the temperature of this system, and we have to measure this length of air column with corresponding temperature. We know that when increasing temperature of the system, air column should expand. When expand in air column, it will move to the out of water in the cylinder. Therefore, there will be an error with reading. Then we have to maintain air column in water for the whole experiment. Therefore, we have to use maximum water height we can use in cylinder. Then answer is level A. Then B. Draw the figure 1. The important missing item in the complete diagram with appropriate size other than water that you should require in experiment. We have to draw the styler for the system. Part C. Give 2 advantages of using mercury thread over water thread in this experiment. First advantage is mercury is not get the glass surface. Mercury does not wet the glass surface. It means when increasing temperature, it is moving immediately and without wetting the glass surface. And we can get another reason. We can calculate without using saturated vapor pressure. If you are using a fluid like water to tap the air column, it will vaporize. Therefore, we have to consider saturated vapor pressure for the experiment, but when using mercury, it will not vaporize. Therefore, we can use pressure without using vapor pressure for the mercury. There are some another reasons we can write. We can get high pressure by using a small thread of mercury. Color of mercury is silver. Then we can identify level clearly. But best reasons are these 2 reasons. Then part D. As the temperature is increased, mercury thread will also expand. Why this experiment does not affect the pressure of that air column? We know that mercury pressure, the pressure acting on air column by mercury thread, is depending on weight of mercury column. When increasing volume due to temperature increasement, mass is constant. Mercury mass is constant. Therefore, mercury pressure is not changing. We can write part D, pressure on air column is depending on weight of mercury fed. It is not changing when expanding. Then part E. In this experiment, you are asked to measure the length L theta of the trapped air column and its temperature. Write down the main steps in experimental procedure which you should follow to ensure that part 1, thermometer reading itself provides the temperature of the trapped air column. Part 2, length theta L itself is exact length corresponding to theta. We can get correct temperature for the air column by styling. We can get correct confirm that the temperature of air column is equal to temperature of water by styling. And we can use another step. We can move Bunsen burner in and out to the system to maintain corresponding correct temperature. If we are measuring 30 degrees temperature, we can increase the temperature of the system up to 31 or more than 31 value. Then we can move out the Bunsen burner to get the correct temperature again. We have to give time to cool the system up to 30 degrees and we can get corresponding length reading. Therefore, we can write by styrene O, move the Bunsen burner, move the burner in and out. In part 2, they have asked the length TL itself is exact length corresponding to theta. We have to ensure there is a steady length of air column, ensuring that there is a steady length. Then part F, if the length of the dry air column inside the capillary tube of uniform, bore diameter of 0 degrees and theta degrees are L0 and L theta respectively. Write down an expression for L theta in terms of gamma p, L0 and theta, where gamma p is the volume expansivity at constant pressure for dry air. We have to use the equation for expansion. We know that volume after expansion L2 should be equal to L1 into 1 plus gamma theta. Now they have given the length corresponding to theta temperature is L theta, initial temperature 0, therefore length corresponding to 0 degrees L naught, 1 plus gamma P. Gamma P means volume expansivity at constant pressure. We are using a constant pressure for whole experiment. Theta is the temperature difference. Now we have increased the temperature from 0 to theta. Therefore we have to get theta as the temperature difference. This is the expression we have to write for part F. Then G. Draw the rough sketch of expected graph with theta S on y-axis and theta in x-axis, theta in Celsius. We know that according to Charles' law, volume is directly proportional to absolute temperature. Absolute temperature means Kelvin temperature. And we know that Kelvin temperature, if we are using Kelvin temperature for x-axis, length also directly proportional to Kelvin temperature. Therefore, we have to draw a graph which is passing the origin. But in the given graph, we are using theta in Celsius and length L theta. Therefore, the graph should pass Kelvin 0. Kelvin 0 means minus 273 Celsius. Therefore, it should pass minus 273. The corresponding graph shape is this. In part H, a student decided to use the capillary tube shown in figure 2 instead of the tube shown in figure 2b experiment when taking a set of readings. It is more advantageous or more disadvantageous. Explain your answer. In the given figure, figure A, they have given that they have given a tube with a part like this. We can grab air column for this part. Then using this tube, we can use a higher volume of air column. Then increasing initial volume for the air column, the expansion also increases. Then we can get a reading with the least fractional error. Then we can write it is advantageous. We have to write that advantageous or disadvantageous. It is advantageous. We can write the reason. Fractional error or percentage error is a small value. We are measuring length of air column. Therefore, length of air column, when length of air column increases, the fractional error is decreasing. You can write, if you can get it is disadvantageous. We can write the reason. We can't get, it is difficult to get a set of readings by using the given tube, because of we have to add always this corresponding length of this part to the L value, L theta value we have obtained. It is difficult to calculate but the most suitable answer is it is advantageous because of fractional error is a small value. But can you perform this experiment properly using an electric hot plate instead of Bunsen burner? Explain your answer. No, we can't use electrical hot plate because of it is difficult to control. The temperature of air column. When using a hot plate, we can't. We can do the practical, but it is difficult to control the temperature. We can control temperature easily by using Bunsen burner.